Start recording.
Hardcore.
Okay, so generics. I think kind of like the if you're kind of like if you see generics from time to time, like the most obvious three types of generics you will run into, or the three categories, is probably something related to a promise and something related to a string, and then kind of like everything else. So if you use my code ever or stuff I've touched, then you might see something like this. So I guess like I think when I first kind of saw this syntax, I think the thing that was the most unclear to me is like what is the relationship between the thing that's with in the angled brackets and the thing that came before it. And I think my first kind of realization when I dove into this is there is no hard relation. Or there's nothing you can infer by just like looking on the outside of this. You actually need to go in and look at the source to see how these two things relate to each other. So to kind of like explain that, I'm going to make two types of generic things. One is a generic function, and the second one is the generic class. So I'm just going to start with a very simple TypeScript function. Return 8. And so say if I want to put this in a variable, then so the thing is with TypeScript, we don't need to add a lot of typing to your files. A lot of it is optional, and a lot of types are TypeScript can just infer and will actually give you correct error messaging for even without adding any types. So if I hover over foo, it knows this is a number, so internally it maintains that information. So it becomes more complicated when you do something. Okay, there's something in functional programming called an identity function. So the identity function returns whatever it's given. Let's see. Oh, that's wrong. 8. So the problem here is that we give it whatever we want to, and it will return the very same thing. So one of the issues with this is that because we can give it anything, it will also return anything. So if I hover over foo now, it will also say, as you kind of expect, that it's an any type. So the question is, how can we type this? Because a lot of situations like this where like something that you give a function has influence on the output, and this is the most basic form of a generic. So basically what we're saying is that we are adding a generic now, and the convention is for generics that have one kind of argument. You use the letter T. I don't know why exactly. So now we're basically saying that T is generic. It doesn't have any direct meaning right now. But now we can actually use this T as the input type. And this is completely valid. So we're basically saying is that the input type is variable, is generic. So whatever we give it will be of type T, and it will also return type T. So this is actually the most basic generic. We basically turned the type itself into a parameter. So if I hover over foo now, it knows that it's, in this case, literally 8. It doesn't say number. But I can also give it someone else joined. So I can also give it a string, any string really. And now we know that foo is a string. So this is really the most basic form, is that whatever you give it, the function will also give it back something in that type. So I can give more examples of that. Say hypothetically we want to give something, or we want to give a function something, and then we'll wrap it into an array for us. So what we can do now is we give it something, which is the parameter. It's hard to explain. The generic type T, and it is returning an array of that very same thing. So if I wrap string now, then foo should be an array of strings. Sorry, this is wrong. There you go. So no foo is an array of strings. This is another example, and there's another, I guess, example we can do. If we want to, we can also give functions other functions. So what if we want to write a function that invokes something for us? So now, basically a callback. So we want to give this a callback. So the simplest kind of way to type this would be something like this. This means that we can give it any function, and now we call that function and return the result. So if we want to call this, then we can send it a function, give me, and this function will return the number 5. Let's see. So what's the result? So it's also, okay, it's void. That makes sense. Because I said this function needs to return void. Let's say I'm going to do any. So this function, we call the invoke function, give it a function, invoke calls that function for us and returns the result. So so how do we type this? So we can also do a generic for that. So basically, now we can actually return the result of the callback into a parameter as well. So again, we're going to use t, and so now the callback will return t, and if the callback returns t, then it means that this function also returns t. So that's broadly how generics work in functions. Does anyone have any questions so far?
Yes.
Okay.
So is t, like kind of going back a step, is t like a replacement for using any?
So it's not really a replacement for any. It's basically saying, it's almost giving, it could be anything in a sense. So in that sense, it's similar. T in this case means that this is just a placeholder type, but it's not any. It basically means that if I'm calling, let's say, go back to the identity function, if I'm calling something with a certain type, then we assign whatever that type is a label t. So it is actually, so
it's if you don't know the type of like the incoming parameter.
Yeah, so you don't know it when you define the function, but you will know it when you call the function. So this is why, so it's not specifically any, it just means that at the time of calling, we know exactly what it is. And because when we call this, Typescript will know at this specific point that since we given it a number, or we gave it a string, because we know it at a point where we're calling, that guarantees that the result of this will also be of that same type. So it is, in a sense, like, yes, in this case, t could be anything, but also it is enforced. So if I, instead of input, I do input to string, I think this should fill. Yeah. Because now it's basically saying that for this to work, you need to give it something that has a toString function. So you cannot just make any assumptions about what comes in and what goes out. Just another example is like if I just return 5, even though I said it will return the same thing as input, it should give an error. 5 is not assignable to constraint of type t because t could be instantiated with a different subtype. So basically saying t could be something else that's not a number.
So t could be 6.
Yeah, but it could also be a string, or it could
be a string, yeah, right.
Or an array. So because of that, it doesn't allow us to do this. So basically, this enforces that whatever is given to identity, this function must return something of the same type.
Evert, do you have any, like, obviously there are some like real world examples for this to have been created, but I can't think of any. Do you have like a somewhat graspable real world example where you would have a function where you would want to have this kind of generic type?
If possible, could we do it with like the resource? like
Yes,
or the video
okay.
type?
I can go to the class because I think the class-based one might actually, it's easier to, for me at least right now, to come up with real-world examples for this. So I'm going to do the class version of this. So in our client, we have something called a resource. And a resource has a get function that returns something. And this will actually, so we'll do an HTTP request here. And this will also have a put request. And to do a put request, you need to give it something. And this will return nothing. So using this, so what's kind of frustrating about this object is that if you actually use this in TypeScript, it means that whenever you do resource at get, so say I have an instance of this, so the problem with this is that you always have, so whatever you're getting back, it's no longer typed. So body is any. So say if you want to give this a type, and I'm just going to make it a little bit easier for myself and just don't do HTTP requests, but actually I'm going to store an actual body in here. So say if we want to say, okay, we in our case, we have a video API and a resource represents a single video. So video might have an ID and a title and maybe a duration. So for we want to create a version of resource that specifically pertains to videos. So we can do that by making it generic. So if we basically give this class a parameter, and that's the parameter t again. So we're basically saying there's a part of this that is generic. Now we're saying that if we have a video resource, we want to, and we do a put request, then the body must be of type video. So we basically make this generic. And when we do get requests, we always get a video back. So this is also generic. Oops. So if I now create a new resource with type video, then I can no longer just do resource that put with like garbage, because I made this a resource with subtype video. Basically, it will say, so this object is not assignable to parameter of type video. So this video here becomes a placeholder for all the t's in this class. So similar.
And so you've typed the t variable as video, as a video type.
Just for this instance. I can also have, I can create another one that's, new resource number. Makes a little bit less sense for an API. Because
so
now
any t is a number.
Yeah, exactly. So now if I do this, I already had that line. Okay, I'm just going to remove this. So now if I do resource get, then this will also, it will be typed as a number, and Visual Studio Code will tell you it is. So basically it's like these parameters become placeholders for anything, like anywhere you want to use them. It is weird.
And is it sort of, sorry?
No, go ahead.
It's sort of like a two-part thing where on the one side you're kind of typing the generic, and the other side is like the placeholder for what you've just typed?
Yeah, so the useful thing for this is that because it is a placeholder, we can have many variations of this. So if you have many different APIs, then we can have a resource video, resource user, resource article, resource thumbnail, and that's why we kind of use this a lot, because we constantly use this pattern. We want to be able to actually type the bodies, for our API. Does that make sense?
Yeah. It's actually clicking. This is a really helpful example.
Cool.
Took a screenshot.
Nice.
So if I see a generic in the wild, in like embedded deep in like complex code, how should I sort of know what to do? Like, it's going to be that type.
Yeah.
But like, what's the best way to approach it?
Yeah. So honestly, like if you just see a random generic, then there's nothing from the outside. So even if I think there's like React.component. Oh wait, I'm not used to Visual Studio. Ugh, don't do that. React. Wow, it just does it for me, but I don't want it. There we go. Component is usually typed as first the props, and then this. Oh my god, this is the worst. I need to press escape. And then the state. So just on the outside, because you happen to know how a React component works, you know the meaning is of props and state. But there's nothing that enforces these two things to have specific meaning. So really the only way you can know for sure what these generic variables mean is by actually diving into the component or using their documentation. I think in a lot of cases it's kind of like, hopefully when you use some other library, it's kind of like implied what it means, like it's well enough documented that you kind of have an idea of what they're for. But yeah, there's nothing you can, just by looking at this, there's no way you can know what this means. You need to actually like read the source or read the documentation. Yeah. So I would say that's basically it. So it's like either for functions or for classes, it becomes a placeholder for a type, and you don't want to say what type it is. You want to actually decide that in other places when you instantiate a class or when you call the function. There's other features related to this, like you can, for instance, you can say, right now I made this a resource number, and say, I don't always want to do this. So I think, it says resource unknown. Okay, that's actually new to me. But you can also say that by default it's an any, or if nothing else is specified, it's always a number. Those things are totally possible. You can also say it must be an object. So say it's a very lame object, key string any. So this is an object. At least that's how you usually type it. So you can say T can be anything, but by default it's just a key value object. However, it must be that, or it must be at least that, or extend that. So you can also do T extends my object. So now you're basically saying that you can give it any type as long as it follows the pattern that it has, every property has a key and it has any value. And if nothing is specified, then we default to this. And you can also have multiple generic parameters that you kind of see in React components. Okay, I think that's all I got.
Okay, that's awesome. Thank you.
Yeah.
Yeah, thank you very much, Evert.
Cool. All right.